So I want to review a few of the topics that we've done in coordinate geometry so far, finding the slope, writing the equations of lines in both slope-intercept and point-slope form, finding the midpoint by averaging the x values and averaging the y values, and the last thing we did, directed line segments, or partitioning line segments, or just dividing them into different parts. So remember that when we're finding a slope, we could always use this slope formula right here, and the only thing we need to do that is two different points on a given line. To write the equation of a line, we could either write it in slope-intercept form if we know what the y-intercept is and know what the slope is, but a lot of the times it's easier to put it into point-slope form that looks like this, where that x1, y1 just represents any point on the line you're looking for. So if you know at least one point and the slope of that line, point-slope form might be the way to go. And remember, for midpoint, we could just take the average of the x's and the average of the y's, and that's always going to break the segment into two congruent parts. So we could say that it breaks, in this case, if m is the midpoint, that AM to MB is in a ratio of 1 to 1. And the last thing we did was when the ratio wasn't 1 to 1 and we wanted it somewhere else other than the middle of the line. So in this case, notice that I broke up AB into 1, 2, 3, 4, 5 equal parts. So 5 parts total. And notice that 2 of those parts were closer to A, and 3 of those parts were closer to B. So I would say that P breaks up AB into a ratio of 2 to 3. And we'll talk about how to do that precisely if it's not so obvious where the point goes. So for something like number 1, when we're writing the equation of a line parallel to 8x plus 6y equals 15 that goes through the point 3, negative 4, there's a couple things we need. Remember, if we're looking to put the line in point-slope form, we only need to figure out what that slope is and any point on the line. In this case, they already gave us a point, so the only thing we're actually looking for is the slope. So in order to do this, you need to remember something about parallel lines, where if you have two parallel lines on a plane, both of them have the same rise over run or the same slope. So if I could figure out what the slope of this line is, then I'd be able to just take that slope and plug into point slope form. So the first thing I look to do is to take the equation of the line they give me and try to write it in slope-intercept form so I could more easily see what the slope is. So I subtracted 8x on both sides, and then I'm going to divide 6 on both sides. Remember to divide everything by 6. So I'm left with y is equal to negative 8 over 6 reduces to negative 4 over 3x plus, well, 15 and 6 are both divisible by 3, so I could rewrite that as 5 over 2. But again, the y-intercept isn't the important part here. It's this slope that we care about. Since parallel lines have the same slope, I have all the information I need now. So I'm going to go back to my point-slope form. Y minus the y value they give me is negative 4. So if I'm subtracting a negative 4, it's going to become plus 4 equals my slope, which is negative 4/3, times x minus the x value for the point they give me, 3. So that is the equation of a line that's going to go through 3, negative 4, but is also parallel to that line. The reason I know that is because they have the same slope of negative 4 over 3. So for number 2, the process is exactly the same. So take a minute to pause the video and see if you could do that one on your own. So when you're finished, your work should look something like this. Remember that when you're dividing two negatives for the slope over here, it becomes positive, and your equation can look like y minus 3 equals 4/5 times x minus 6. Now, if you wanted to get this into slope-intercept form, you could, but unless the problem explicitly asks for it, this is going to be the easier form to leave it in. You could always distribute that 4/5 and add 3 on both sides, but in this case there's no reason to, so we're not going to. For number 3, a very similar problem, but in this case we want to write the equation of a line that is perpendicular to the line that we're given. Remember, perpendicular lines have negative reciprocal slopes. So for example, if I find that the slope of this line is 1/2, the negative reciprocal of that is going to be negative 2/1 or just -2. So keep that in mind as you're going through this one. So I'm still going to solve for y. So 2y equals 6x plus 2 if I just add 2 on both sides. And I divide everything by 2 to get y by itself. So I'm getting the line they give me into slope-intercept form so I could figure out what the slope is. So in this case I see the slope is 3, but that's not the slope I'm going to use when I plug into point slope form. I want the negative reciprocal of 3. So the negative reciprocal of 3, well, we could think about 3 as 3/1, and since it's positive, it's going to become negative 1/3. So I just negated and flipped the fraction. So this is the slope we're going to use. So when we plug in, y minus 1 equals, my slope is negative 1/3 times x minus a -7, so it's going to become plus 7. And that's what your line would look like. For number 4, it asks, write the equation of a line that intersects y equals -3 at a right angle and that passes through the point 1, 4. So this is a very similar problem to the last one, because you need to recognize that if lines intersect at a right angle, those are perpendicular lines. So we could get something going with the negative reciprocal slopes here, but I'm just going to plot this line to see what it looks like so we could visualize it. So for y equals -3, I go down to -3, and if the line is y equals -3, that means all the points on that line have a y value of -3. So I'm just going to draw a straight horizontal line through -3. So that's what y equals -3 looks like. And I want it to go through the point 1, 4. So somewhere up here, that's the point I want it to go through. So if it intersects at a right angle, it's going to go straight up like that. And I know this is a vertical line. So you need to ask yourself, what's a special property of a vertical line? Well, if I pick this point right here, that would maybe be 1, 1. If I pick this point down here, I still went right 1, and then I went down 1. It's looking like for all of these points, the x value has to be 1. So vertical lines are always of the form x equals some constant. And in this case, the x value we want is x equals 1. And you could tell just by looking at whatever the x value of the point they give you in the problem is. For number 6, we're given 4 points, A, B, C, and D, and we want to figure out if the segments AB and CD are parallel. So I've already plotted these and connected them, and it looks like they could be, but we want to have math to justify why they're parallel. Remember that parallel lines are lines that have the same slope. So if I can figure out if A to B and D to C have the same slope, then I'd be done. So I'm going to find the slope for AB, and I'm going to find the slope for CD and compare them. If they are parallel, then they should be the same. So remember, slope is y2 minus y1 over x2 minus x1. So I'm going to start with a and b. So I'll take 5 minus 2, that's going to be over negative 1, minus a negative 5 becomes plus 5. So 5 minus 2 is 3 over 4. For CD, that's going to be negative 1 minus 2 over negative 1 minus 3. So that's negative 3 over negative 4, and remember, a negative divided by a negative becomes positive. So in this case, I got the same slope for both of them. So I would say that yes, AB is in fact parallel to CD. My reason being is because parallel lines have the same slope. So you don't need to write a formal statement reason proof for these as long as you have enough math to justify why they're parallel. And you could have also went to the graph and counted up and counted to the right, but it won't always work out to be good numbers where it's whole numbers for the boxes. So plugging into the slope formula is going to be a sure bet to get it every time. For number 7, they give us 4 points again, but instead of asking us to prove if the segments are parallel, we're instead asked to prove that they're perpendicular. So if we could figure out the slopes of them, we'd be able to compare EF to GH and say whether or not these slopes are negative reciprocals of each other. Because remember that parallel lines have negative reciprocal slopes. So I plotted them here. It looks like they could be, maybe up to my drawing it might be a little inaccurate, but they tell me to prove that they're perpendicular, so they should be perpendicular. So I'm going to go to my slope formula again. So I'm going to find the slope of EF, and I'm going to find the slope of GH. And notice that I'm just using EF and GH as subscripts, so I can tell these two slopes apart. So again, negative 9 minus 1 over 5 minus 0 is negative 10 over 5, or negative 2. So before I even keep going, if these segments are perpendicular, I'm going to want to find the negative reciprocal of that as the other slope. So I'm thinking I should get positive 1/2. Let's see what happens. Negative 4 minus a negative 5 becomes plus 5. And 4 minus a negative 2 becomes plus 2. So we get 3 over 6, which simplifies to 1/2. So indeed, these segments are perpendicular. Reason being, perpendicular lines have negative reciprocal slopes. For number 8, if I want to find the midpoint between 2 points, there's a couple different ways you could do that. You could find the slope between the 2 points and then try to divide that by 2 and see what you can get going there. But the easiest way to do this is to just take the average of the x values and the average of the y values. Because remember, to find a number right in between two numbers, you could just find the average between them. So, in this case, negative 4 plus 2 over 2 is going to be my x-coordinate, and 5 plus 1 over 2 is going to be my y-coordinate. So negative 4 plus 2 is negative 2, divided by 2 is negative 1, and 5 plus 1 is 6, divided by 2 is 3. So if I go left 1 and up 3, this should be my midpoint right here. That breaks AB up into a ratio of 1 to 1. So AM to MB is 1 to 1. Now that's not the only way you could have done this. A way that might be more useful to think about is if I just have my 2 points right here, my A and my B. Negative 4 comma 5 and 2 comma 1. from -4 to 2, my x value increased by 6 units. Because to get from -4 to 2, you could count up 6. So if you want to find half of that, to get to your x-coordinate of your midpoint, you'd have to go up 3 units. So in this case, this would have to be -1, which matches what we had before. And a similar argument for our y values. Between 1 and 5, we went up, oh no, excuse me, we went down 4 units. So half of that would be going down 2 units. So down 2 units from 5 would get me to 3. So that's another way you could think about getting the midpoint, depending on what information you're given. So number 9 is another midpoint problem, but in this case they tell me that the midpoint is located at -3, 0, and that one of the endpoints is at 1, 4. So now we're looking for one of the endpoints x, y. So there's a couple different ways you could do this. If you want to use the midpoint formula, you could, by just saying that one of your x values for your endpoints is x, plus the x value for D was 1, divided by 2 is equal to the x value for your midpoint. And you could make a similar equation for your y value. So y plus 4, the cy and the dy is equal to the y value of the midpoint. And you could solve those equations and get coordinates for C. An easier way to do that, though, is just by counting to find the slope between D and M. So to get from D to M, you would have to go 1, 2, 3, 4. You'd have to subtract 4 from your y value. So in my head, I'm already thinking, well, if I subtract 4 from the y value of my midpoint, I should get to where I'm going, because it needs to be the same distance from D to M, from M to C. And to get back to M, I go 1, 2, 3, 4, 4 to the left. And remember, if I'm moving to the left, I'm subtracting x values. So I could subtract 4 from the x value for the midpoint as well to get -7, 4. So -7, 1, 2, 3, -4. So this looks like it could very well be the other endpoint. To check, you could solve both these equations and note that you will get x equals -7 and y equals -4 when you multiply by 2 on both sides and isolate x and isolate y. For number 10, given the coordinates of A, B, C, and D, prove that segments AB and CD bisect each other. Remember that bisectors mean that you're cutting something into 2 congruent parts. So for example, when we did the perpendicular bisector early in the year, when that perpendicular line cut through whatever segment we had, it would hit the segment at the midpoint. So in this case, for this sort of problem, if we could figure out whatever the midpoint for AB is, and then figure out whatever the midpoint for CD is, if those midpoints are the same coordinate, then it is true that when these 2 segments intersect, that's going to be where they bisect each other. So, I'm going to use the midpoint formula for both of these segments. So, for AB, that's going to look like my 2 x values, so 1 plus -4 is the same as 1 minus 4, and summing my 2 y values and dividing by 2. So I'm averaging the x's and averaging the y's. So I get 3 over 2, comma, 5 plus 1 is 6, divided by 2 is 3. For CD, when we add those up, we get -5 plus 2 over 2, and 2 plus 4 over 2. So again, when we simplify this, we get -3 over 2, comma, 3. So if I go over 1 1/2 and I go up 1, 2, 3, yes, they do have a common midpoint. So since their midpoints are the same, these two segments do bisect each other. So if I was asked to explain myself for a problem like this, I would show this work showing that I got the midpoints for both the segments, and I would say that since both these segments have the same midpoint, they must bisect each other. For number 11, on segment AB with endpoints -8, -8, and B at 2, 7, find a point P that breaks the segment into a ratio of 2 to 3 with P closer to A. So remember that if we're breaking something into a ratio of 2 to 3, that means it's 2 parts to 3 parts. So together we're breaking it into 5 parts. So in my head, I draw this horizontal line and break it up into 5 equal parts, so that if P is closer to A, then by the time we're finished, it should look something like this, where we've got 2 parts of the 5 that are closer to A, and 3 parts of the remaining, so 3 remaining out of the 5, closer to B. So P should be somewhere in this vicinity by the time we're done. So the way we do that is by starting and finding the total change in X and the total change in Y. So you could do that by counting boxes here, but in this case, it's just easier to subtract the X values. So if I subtract 2 and -8, that becomes 2 plus 8, or just 10. So my total horizontal change from left to right, I would have to move 10 units to the right to get directly under B right there. And for my Y values, if I subtract those, Y2 minus Y1 is equal to 7 minus -8, so 7 plus 8, or 15. So my total change in Y is 15. So I would have to move 15 units up to get to B. But we don't want to move 10 units to the right and 15 units up. We only want to move 2/5 of the way up this line, such that when I have the point P, AP to PB is 2 to 3. So 2 out of the 5 parts compared to 3 out of the 5 parts. And the way we do that is by taking our starting point A and adding to it 2/5 of the total change in X and 2/5 of the total change in Y. If you were moving down, if this was a downward sloping line, you would just subtract those values. So I look at my point A, which is at -8, -8. And I'm going to add to that. So I'm going to add to the X value 2/5 times my total change in X, which in this case is 10. And for my Y value, I'm going to add to that 2/5 my total change in Y. So -8 plus 2/5 times 15. Because that would represent the total how far I need to go up, but I'm not going up all the way. I'm only going up 2/5 of the way. So this becomes -8 plus 2/5 times 10 is just 4. And -8 plus 2/5 times 15, well, 5 goes into 15 3 times, so that's plus 6. So I get my final coordinate to be -4, -2. And I always like to have some graph paper out when I'm doing these, just so I could visualize it when I'm finished to make sure I didn't make any mistakes when I was adding or subtracting however much I needed to from the total change in X and Y. So I go left 4, down 2, and this would be where point P is. So I ask myself, does that look like that could be 2 pieces compared to 3 pieces? Well, it looks like AP is a little bit smaller than PB, so in this case everything worked out. So my coordinates for P would be -4, -2. For number 12, with directed line segment AB that has endpoints -8, -2, and 16, 6, we need to find a point P that divides AB such that AP to PB is 3 to 5. So we want to find some sort of point P that breaks this into a ratio of 3 to 5, which means that the whole line segment is broken up into 3 plus 5, or 8 parts. So I'm going to do the same thing, where I subtract my x values to get my total change in x, and I subtract my y values to get my total change in y. So in this case, 16 minus a -8 becomes 16 plus 8, or 24, so that's my total change in x. And for my y's, 6 minus a -2 becomes 6 plus 2, or 8. So my total change in x is 24, and my total change in y is 8. So I'm going to, just to visualize this, -8, -2, so A is somewhere over here, and 16, 6, so B is somewhere over here. So I know I'm moving right and up, so I'm going to add both these values to my initial coordinate. So if I'm looking at the coordinates of A, that -8, -2, I'm not going to add 2/5 like I did before. I need 3 parts out of my total 8 parts. So what this is going to look like is -8 plus 3/8 of my total change in x, which is 24. And for my y coordinate, I'm going to add to that 3/8 of my total change in y, which was 8. So -8 plus 3/5 times 24 is 9, and -2 plus 3. So my final coordinate is +1, +1. So this would be where P is located. And again, I give myself a rough estimate of 1, 1. So it looks like it's going to be on that line. My picture is not very accurate, but if you have a set of graph paper, it's easier to graph this. And it should be a little bit closer to A than it is to B, so everything checks out here.